unit conversions. And this is probably going to take, I don't know, it's going to take me about probably 10 minutes to talk about this, and then you guys ask questions, and then that will be it. So not too long. Okay, so the basic concept here, right, is especially if you don't have this written down somewhere, in your notes already, we're going to talk about converting between the different units of the metric system. So you definitely want to have this idea of the meter being the base unit. And then from there, we can have deci, centi, milli, right? They also talk about micro. Oops, sorry, you guys can't see that. They also talk about micro units, which I'll just write up here. You usually see them written as this interesting little U. And then we also can see nano, micro and nano. So those two you don't really see too often, the micro and the nano. So I'm going to have them listed here, but you're probably not going to need to use those frequently. But the meter going to decimeter, centimeter, millimeter, definitely important. And then also going the opposite way. So there's the decameter. I think it has a T in it, actually. Pretty much never used. The hectometer, also hectometer, pretty much never used. And then kilometer, used a lot, right? Centi's used a lot, milli's used a lot. So those are going to be the more common ones. But the cool thing about this is that you can just move the decimal around to solve these problems. So if we're going to the left, we can move the decimal. If we're going to the right, we can move the decimal just for these. For micro and nano, you need to move the decimal a few more times. So I'm going to show you what I'm talking about. So meter, let's say we have 100 meters, and we want to convert that into kilometers. Okay, well, to get from a meter to a kilometer, I had to move the decimal 1, 2, 3 times to the left. Guess what I do for meters? I put a decimal at the end of my number. I move my decimal 1, 2, 3 times to the left. 100 meters is equal to 0.1 kilometers. That's like a little shortcut, right? Same thing if I want to go the opposite way. Let's say I want to go from 100 meters and I want to get to centimeters. So I put my decimal in the same place at the end of my number. To go from meter to centimeter, I moved 2 times. So I'm going to do that. I'm going to move my decimal 2 times to the right, and I'm going to add zeros in there. And I get that there are 10,000 centimeters in 100 meters. And this should kind of make sense logically to us because centimeters are tiny, right? So there's going to be a lot of them in 1 meter, or in 100 meters, there's going to be 10,000 of them. So the American system doesn't work like this, right? But in the metric system, you can literally move the decimal. This is a lifesaver right here to be able to do that. You can also multiply by 10 to the negative 3 and all that other stuff that they showed in the lesson. But I find this to be way faster. Okay, so that's the first step, is understanding the relationship between the metric system here, that it's all in increments of 10, right? Which is really helpful when we're doing unit conversion stuff. Now, you guys probably feel all right with that, right? You're like, okay, that doesn't seem too crazy. Where it starts getting hard is when we enter this concept of dimensional analysis. And what I want you to think about when you hear this or see this is really, this is basically like crossing out all the units. So you want to cross out units until you're left with the units you want. Until you have the correct, I was going to say right, but the correct unit. So for example, if we have 3.5 centimeters per second, this is a speed, right? Someone's moving at 3.5 centimeters a second. Okay, well, that really doesn't tell us much because we're like a centimeter is really tiny. That's not really moving very fast, maybe, or maybe it is. We don't know. So if we want to convert that into meters per, or kilometers even, I'm getting a phone call. Excuse me 1 second, guys. Hello? Could I call you back around 3 o'clock? I'm doing a really quick emergency Zoom session with my chemistry students. Okay, I'll call you back in probably about 30 minutes or so. Okay, thank you, bye. Okay, so we want to figure out what that means in kilometers per hour, right? So we have two conversions we have to do here. First of all, we have to get from centimeters to kilometers. Second of all, we have to get from seconds to hours. So when we do these dimensional analysis, we're going to set up sort of like a table almost. We're going to write our 3.5 centimeters. We're going to put it over seconds, right? You can put a 1 here if you want, if it makes you feel better, because technically there is a 1 there, right? And dividing something by 1 is going to be the same thing. We're going to be multiplying that by a bunch of different things until we can get to the correct conversion here. So let's start with seconds to hours. How many seconds are in a minute? You could type in the chat. Uh-oh. Do we know how many seconds are in a minute? There are 60 seconds in 1 minute. The reason I'm going this way, right, is because you want to think of what, thank you, Brina. Is it Brina or Brenna? We want to do conversions that we know, right? We can get from seconds to minutes, and then we can go from minutes to hours, right? So now notice I put seconds on top here because now those are going to cross out. And now I'm actually in centimeters per minute. So I'm getting closer. That's okay. And so now I know that we have 60 minutes in 1 hour. My minutes cross out. And I'm left with hours. Well, guess what? I want hours. So I'm going to stay there. I already converted seconds. Now I need to move into the centimeters. So I need to convert centimeters into kilometers. I could do this in a bunch of steps, or I could do it in 1 step using what we just talked about, right? If I have my metric system set up here, if I'm going from centimeters to kilometers, I'm going to move the decimal 1, 2, 3, 4, 5 times to the left. So I have 3.5 centimeters. I already have a decimal here. I have to go 5 places to the left. 1, 2, 3, 4, 5. So I'm going to be adding 4 zeros there. So what does that tell me? That tells me that, well, actually, this is not going to be easy to explain to you guys in dimensional analysis. We could put that in there, but we won't. So we'll do the same way that we did with the seconds to minutes. Sorry about that. I'm getting ahead of myself here because I have done dimensional analysis many times, and I'm remembering, you guys, this is like an intro here to this. So we're going to want to start by going from centimeters maybe to meters. So if we want to cross out centimeters, we're going to put it on the bottom. We're going to put meters on the top. How many centimeters are in a meter? Right? Well, if we look at the relationship between them, it's 2 decimal places, which really means that there's 100 centimeters in 1 meter, right? Because if I'm moving the decimal place 2 places to the right, I'm taking 100 and I'm going 2 places to the right to get 1. So 100 centimeters in 1 meter, I can use that. 100 centimeters, 1 meter. Okay, I have to go down onto the next line because I don't have enough space. So I wrote huge here. But our final thing, right, we've crossed out centimeters now. We have meters. We need to get to kilometers. So how many meters are in a kilometer, right? We can refer back to our chart. You could also look it up. You could also memorize it. But we're moving 1, 2, 3 places, right? There's actually 1,000 meters in 1 kilometer. We could check that. We would have to move to go from meters to kilometers, we would have to move the decimal 3 places, 1, 2, 3, right? Checks out. So back to our dimensional analysis. We know that there are 1,000 meters in 1 kilometer. Meters are now crossed out. We're left with kilometers per hour for our units. So units look good. That's what we want. Now we just have to do the math to figure all this out. So using your calculator, or you could even type it into your computer, right, or use the computer calculator, we're just going to try to multiply all this stuff out and see what we get. So I can get my calculator open here. Okay, we're going to be doing 3.5 times 60 times 60. And then we're going to be dividing that by 100 and dividing everything by 1,000. And we end up getting 0.126. And that's our answer. So 3.5 centimeters per second is equivalent to 0.126 kilometers per hour, right? Which is really slow. If you think about a kilometer per hour, that's actually how you would measure speed in a car, right? It's not exactly equal to miles per hour, but it's similar, right? So this is a tiny and slow speed. Okay, so we're going to do a couple more of these, and then I'm going to take questions from you guys from the quiz. And you guys feel free to just pop a question in the chat if, as we're going through this, you're like, what are you doing? Or can you explain that again, etc. But remember, the whole process here, the whole concept is we want to cross out the units that we don't want. And we're going to use a whole bunch of different conversions. Okay. So let's say that our next one here, we're going to do, we want to go from 5.7 grams per liter, and we want to know what that is in milliliters. So we're going to set it up the same way. We're going to put our 5.7 grams over liters. Right, and we're going to start, I personally like to start with getting rid of the bottom, right, but it's up to you. You can start the other way as well. You're going to get the same answer. But I'm going to start with liters here. So I need to know how many milliliters are in a liter. This can be replaced, instead of meter, this can be liter. This can be gram. Those are all base units of the metric system, right? So we can use that conversion concept here. So if I have 1 liter and I want to know how many milliliters it is, to get to milliliters, I'm going to have to move the decimal to the right 1, 2, 3 times. 1, 2, 3. So I'm going to be adding 3 zeros. And eventually you're going to remember a lot of this stuff. Like I have that memorized, for example, that there's 1,000 milliliters in 1 liter. Okay, so I go back to my dimensional analysis. I now know that 1 liter is equal to 1,000 milliliters. And this part is a little confusing too, I think, when you start multiplying by stuff, because you're like, wait, why are we multiplying? Right? Technically, we're multiplying by 1. These are equivalent. So we're really not multiplying anything, right? Which is even more maybe trippy. But regardless, these are equivalent. And that's why we need to make sure they're equivalent, right? Because we don't want to multiply by anything. We don't want to change our answer. We just want to change the units. So that will cross our liters out and leave us with milliliters, which is great. That's what we're asked in the question, right? So now we have the grams left here. So I'm going to put grams on the bottom. And I want to know how many milligrams are in 1 gram. Well, guess what? It's the same as milliliters, right? There are 1,000 milligrams in 1 gram. And we could always go back and look at this base metric units chart, right? And we could check that 1 gram to get to milligrams, we're gonna have to move the decimal to the right 1, 2, 3 times so that we get 1,000. So I'm gonna be putting 1,000 milligrams on the top. That will get rid of my grams, and I'm left with milligrams per milliliter, which is what I want. Now here's something interesting. If we did this math, right, we have 5.7. If we multiply by 1,000 and then divide by 1,000, guess what? It's the same thing. Our answer is going to be 5.7 milligrams per milliliter. And the reason that it works out that way is because we're going from, in this case, grams and liters to milligrams and milliliters. So we're doing the same conversion. So that one's kind of like a trick one. But still, it's good to set it up, right, to check. Make sure that everything crosses out. So then we can end up getting into much harder questions, right? I looked through the quiz. I didn't see any super hard ones, but let me show you. I had something open earlier that I was looking at that I thought could be a good example for us. Okay, so these can become like really complicated word problems, right? As you become better at them too, you might want to challenge yourself with them. But let's say we're throwing a pizza party for 15 people, and you can see the answer there, but I'm still going to walk you through how to do it anyways. And figure that each person will eat 4 slices. You call up the pizza place and learn, which is spelled wrong, that each pizza will cost you $14.78, and it will be cut into 12 slices. How much is the pizza going to cost you? You only have $70. Will you have enough money? Okay, so first of all, from some kind of question like this, where we're not going to be using normal conversions, in other words, we're not going to be using conversions that we're used to using, like milliliters and grams, etc. We want to make sure we write down those conversions so that when we do need them, we can refer to them. So, oh, look at that. I could cover the work up. Okay. So what do we know from the question, right? Well, we know that we have 15 people. We know that each person, so we know that there's 4 slices per 1 person, right? 1 person eats 4 slices. We know that it's $14.78 per 1 pizza. And we know that 1 pizza is 12 slices. Okay, so that's all the information I got. Okay, so basically what we're going to be doing here, if we want to think in terms of units, is we're going to be converting from people into money, right? Eventually we want to know how much money this is going to cost. So we're going to start off with our 15 people. And we want to look at the information we know. If there's any way that we can cross out people. Well, guess what? We can. Person, people, same thing, right? We need people to be on the bottom. It is great. It doesn't matter though, because since this is 1, we could easily switch it around the other direction, right? It could be 1 person per 4 slices because it equals 1. Doesn't matter in which order you put it in. But we're going to be putting our 15 people over 1. Now this is a new situation. We don't have a unit here. That's okay. We're multiplying now by 4 slices per, we'll say, 1 person, right? But that's going to help us get rid of people. Okay, now we need to get rid of slices. Well, guess what? We know here a ratio about slices to the pizza. So now we're going to multiply. We know that 1 pizza has 12 slices. Slices go away. Now we're with pizzas. Now we know 1 pizza costs $14.78. That gets rid of pizza. And guess what? We're left with dollars, right? Which is kind of a unit. It's just a unit in front. And that's what we want, right? We want to know if we have enough money. So now we just have to do the math part. So we're going to multiply. Oops, covering up my numbers here. So we have 15 people, 4 slices, divided by 12 slices, and times 14.78. And we get that it's going to cost us $73.90. So if we look back at the question, do we have enough money? No, right? We need $3.90 if we're going to buy that many pizzas. Or somebody's going to have to just, actually several people are going to have to suck it up and not get 4 slices, which seems like a lot of slices. Okay. So I've given you guys a couple of examples with the metric system, right? And here was another example where we used sort of arbitrary units. Right? It really doesn't matter as long as you're writing out what the units are and you have conversions between them. You can also go between metric and American, right? So you might have seen some questions where you're going from possibly meters into yards or feet, right? Any kind of situation like that, you're usually given those conversions. So you'll learn that 3 yards is in 1, no. Is that right? 3 yards is 1 foot? What does 3 yards equal to? I don't know. I don't know anything about the English system, so I'm not even going to pretend that I know that. Metric system, I understand because it's in tens. Okay, so now I want you guys to ask me questions. So we can do a problem from the quiz. Now keep in mind, you might have different questions on your quiz than other people had. So if you could please paste the question in, that would be awesome. If you want me to just do more examples because you just want to see how this works more, that could be a question. Can you do more examples? If you feel like you kind of understand what's going on and you don't want to be in the session anymore, you're welcome to leave. But you guys let me know what you want to do because I want to do whatever's going to benefit you the most. Some more examples. Okay, awesome. Do you want to do more word problem-y ones like this, or do you want to go back to doing more simple ones like going from milligrams to milliliters? Okay, good. Yeah, dimensional analysis is hard, guys. This is college level stuff, actually. So if you end up doing science in college, you will see this again, right? If you take any AP classes or do early college or anything like that, you will see dimensional analysis. Really, I think the hardest part about it is just realizing that all you're doing is crossing out units, right? Because if you try to think about the question too much, at least for me, I end up doing some weird stuff and I get it wrong. If I just do dimensional analysis and just trust that crossing stuff out is going to work, it works. It's really strange. Trust me, I was not a believer. I was very against this when I first learned it. I was like, what is this? This doesn't make any sense. Now I'm like, oh, this is so easy. Not really. It's still actually pretty hard. All right, so let's see. Let me find some more possibilities. Let's see. Okay. Ooh, let's do this pen one. Okay, we're going to try one together where we're all going to try to work it out. So, in my chemistry class, 28 students are each given 3 pens. Okay. So I'm going to help you guys write out what we learned from the problem, and then I'm going to give you a couple of minutes to try to set it up on your own, and then we'll go through it together. And then we'll do a little easier one. So we know that we have 28 people. We know that we have 3 pens per 1 person, right? Each person gets a pen, 3 pens. We also know that there's 8 pens in 1 package of pens. We know that 1 package is priced at $1.88 per package. So we want to know how much money did that chemistry teacher just spend to give everyone 3 pens. Okay, so I am going to stop my, no, because then you can still see my thing here. Okay, I'm just going to move my paper away while you guys look at this beautiful green paper. Let's spend 2 minutes just trying to set up. In fact, I'll just leave this here, but I'll write on a different paper. How's that? That way you guys can still see those. So spend like 2 minutes, just try to set up the dimensional analysis for this question by yourself. We're looking for cost. Keep that in mind. Cost is what we want. Okay, so hopefully you tried to set that up, right? This is how I set it up. I just started with all that information that I already knew, right? I knew there were 28 people. I put that over 1 because there's no bottom unit here. I'm multiplying by 3 pens per person so that I can cross out people. I'm multiplying that by 1 package having 8 pens, right? Because pens cross out. I'm multiplying that by $1.88 per package. So that package cancels out and I'm left with just money. So I multiplied 28 times 3 divided by 8 and multiplied by 1.88. And I got that it will cost $19.74 to hand out those pens. Okay, if you need to go, go ahead. Hopefully this helped you. Okay, and then we'll do one more example here, since it'll just be me and Larissa. And I did record this in case other people want to see it. But our last one is going to be back to kind of what we talked about in the beginning. Same thing, I'm going to let you try it, and then we'll go over it. So our last example here is going to be, if we have 100 liters an hour, right? This could be a measurement possibly of water, maybe moving through pipes or something like that. And we want to convert it to milliliters per second. What do we need to do? Right? And you could even, before you start setting up the dimensional analysis, you could think about what conversions you know. Between those, we're definitely going to have to go from liters to milliliters, right? So I know that there are 1,000 milliliters in 1 liter. And how do I know that, right? I would just go right back to this metric system thing. I would say, okay, if I have 1 liter, how do I get to milliliters? I'm going to move my decimal place 3 times to the right. So I'm going to have 1,000 milliliters. Okay, so take a second, see if you can set it up, and I'm going to set mine up and then we will compare. Okay, so I set it up like this. I kind of messed up at first because I was trying to cancel out hours and I did some weird thing there and I was like, oops. So I wrote, well, we know 100 liters per hour. Could put a 1 there. And I want to convert. So I know there are 60 minutes in an hour. So I can cross out my hours. Now I'm in minutes. I know there are 60 seconds in 1 minute. So I can cancel out my minutes. Now I'm in seconds, right? Seconds is what was asked in the question, milliliters per second. And now I need to get to that milliliters. So I already knew this one here from before, but 1 liter is equal to 1,000 milliliters. My liters cross out, and I'm left with milliliters per second. And then when I multiply 100, or excuse me, take 100 and I divide it by 60, divide it by 60 again, and then multiply by 1,000, I end up getting 27.78 milliliters per second, which kind of makes sense, right? Because milliliters are smaller than liters, we expect our answer to be smaller than 100, for sure. Okay. How are you feeling, Larissa? Okay, good. And something else too, we're going to do a mole lab this Friday, which involves some of this unit conversion stuff. So we're going to keep practicing this. Okay, so this is not the first time that we're going to do it. And right now I'll just go in and give you a retake on the quiz. All right. And then if you miss any specific questions or anything, you can always send me an email. Just copy and paste the question, because like I said, sometimes people have different questions, right? So when I look at the quiz, I see all the questions. I don't know which ones you got. So if there's a one or two in particular that you're just like, I have no idea what this is, just send me an email and then we can walk through the steps. Okay, so otherwise, I am going to end this meeting, and I hope this really helped you guys, and I'll see you soon.